Hey everyone, welcome to my talk about observability of microservices using open source tools. Hope you're having a good time at the conference so far and that you take away something valuable from my talk. So, a quick introduction to break the ice. Hi, I'm Shubham and I'm a developer relations engineer at ZenUD. It's an advanced incident management and response orchestration platform. I'm an expert in making mistakes, learning from them, and advocating for best practices for org setting up their DevOps, SRE, and production engineering teams. So the burning question, what is this talk about? So firstly, we'll have a quick brief on observability, something I'm sure the brilliant speakers before me must have done a good job covering, but we'll quickly glance on the same. Why we need observability from day one. Then we're going to be setting up an observability system using open source tools in record time. And finally, we'll talk about what comes after you have observability set up. So again, what is observability? It's the ability to measure the internal states of the system by just examining its outputs. So observability gives engineers a rather proactive approach to optimizing the system. It provides a connected real-time view of all the operational data in your software system, as well as the flexibility to ask the question on the fly about your applications and get the answers that you need. And that is the key part, having to know ahead of time what you wanted to ask. It's also about understanding the service level required to meet the customer needs and then instrumenting the necessary components to ensure that the desired level of performance is achieved. It is not about collecting a colossal amount of data to just have all the time, but rather the right metrics to track and monitor the key performance indicators relevant to your software and adapting the system to meet the customer expectations. So why do I keep hearing about it all the time now? It's the word has been thrown around everywhere, and every fourth post on LinkedIn does have observability as the core concept. It's a fair question. We've been around for a considerably long time now, and the buzz around the word has begun to catch on only very recently, like about 5 to 6 years ago. Why now? And well, simply put, software complexity is increasing at an exponential rate, and products are innovating in a crazy, unpredictable direction. On the infrastructure side, microservices, polyglot persistence, and containers are enabling the decomposition of monoliths into agile, complex, ever-evolving systems. Meanwhile, on the product side and platform side, creative solutions are empowering users to do new and exciting things. However, it creates challenges for developers to make stable and reliable components. As recently as 5 years ago, I think most systems were much simpler. You'd have a classic LAMP stack, one big database, an app tier, a web layer, a caching layer, some basic load balancing, and you could predict most failures, craft a few dashboards that addressed nearly every performance RCA that you might need over the course of time. And your team did not spend a lot of time chasing known unknowns, and it was relatively easy to find out what was really going on behind the scenes. But now, with a platform or a microservices architecture or millions of unique users or applications connected, you have a long, fat line of unique questions to answer all the time. There are many more potential combinations of things going wrong, and sometimes they connect in a manner that is hard to decipher. Now, why do we need day one observability? Why are we solving a problem before it even exists, right? When environments are as complex as they are today, simply monitoring for known problems doesn't understand the growing number of new issues that arise. So these new issues, the unknown unknowns that we talked about earlier, mean that in an observable system, you know what is causing the problem, and you don't have a standard starting point to find out. So without deep observability, it is natural to make assumptions about production system behavior, including what we think may be potential performance bottlenecks or failure scenarios. When failures do occur, we are often in the dark as to whether they have occurred and both the impact and potential fixes. This leads to wasted time and effort like throughout the organization, jumping from one theory to another, one change to another maybe, and you really do not understand how any of this is going to impact the system. If customers are impacted, cost of the guesswork is exponentially high, and it can escalate as quickly for any stage. And in production, while Kubernetes can help recover from some failures, we've seen it be a lifesaver for a lot of organizations. But there are many scenarios where that can cause system to run suboptimally or fail continuously even. And even when service availability is maintained, performance bottlenecks can result in premature auto scaling, resulting in the excessive use of costly cloud computing resources, to say the very least. Indeed, there are cases where the first signs of failure is an astronomically high cloud computing bill. So now, without any further stalling, let's move on to the meat of it, building a complete open source solution for extracting and shipping traces, metrics, and logs, and correlating between them. So a few prerequisites to fulfill this demo. First up, we have the Kind tool. Kind is a tool for running local Kubernetes clusters using Docker container nodes. Kind was primarily designed for testing Kubernetes itself. And yeah, if you have Go 1.17 plus and Docker installed, all you have to do is run this command to install and run Kind locally. I'll be sharing all links, snippets, and resources I mentioned in the talk in a gist, and you can find the link for the same down below. Next up, we have kubectl, the Kubernetes command line tool, which allows us to run commands against Kubernetes clusters. And finally, we have Helm. Helm helps us manage Kubernetes applications via Helm charts, which help us define, install, and upgrade even the most complex K8s applications. So let's move on to the observability backend. As there is currently no one database that can store all logs, traces, and metrics, we will deploy 3 different databases and the visualization tool. So we have Grafana for dashboards and visualization of the data. We have Prometheus. It records real-time metrics in a time series database. It allows for high dimensionality with flexible queries and real-time alerting. We'll use Loki, which is a horizontally scalable, highly available, and multi-tenant log aggregation system inspired by Prometheus. And finally, we'll use Tempo, which is an easy-to-use and highly scalable distributed tracing backend. Tempo is cost-efficient and requires only object storage to operate. And it offers, naturally, it offers very deep integrations with Grafana, Prometheus, and Loki. So now we need the observability control plane, which will automatically instrument our applications. And for that, we'll be using Odigos. So Odigos is an open source observability control plane that helps us in 2 ways. Firstly, automatic instrumentation. Odigos automatically instruments your applications and produces distributed traces and metrics without any code changes. And collector management, which is Odigos automatically deploys and scales collectors according to application traffic. So we don't need to spend a lot of time deploying and configuring collectors. So now for this demonstration, our target application will be a microservices based application written in Java or Python. We'll be using a fork of the bank of Anthos example application, which was made by Google, and you can find the link in the resource section. You can deploy the target application by simply running the following code, and you should be good to go. To install the observability backend, we'll execute the following Helm chart, which deploys Tempo, the traces database, Prometheus, the metrics database, and Loki, the logs database, as well as a pre-configured Grafana instance with those databases as the data sources. So once our test application is up and running, our observability databases have been set up and ready to receive data. We'll install Odigos as the control plane to collect and transfer logs, metrics, and traces from our applications to the observability database. So to install Odigos via the Helm chart, you just need to execute the following commands. And after all the pods in the Odigos system namespace are running, we need to open the Odigos UI by running the port forward command. Once that's done, all you need to do is navigate to localhost :3000 to see your Odigos set up and ready to go. So now there are 2 ways to select which applications Odigos should instrument. The first one is opting out, basically which will instrument everything, including every new application that will be deployed in the future. You can still exclude any application that you do not want to be instrumented. And the other way is opting in, where you select only a certain few applications that you want to be instrumented. And for the purposes of this tutorial, we'll use the simple way out, which is opt out and instrumenting everything. So the next step is to tell Audigos how to reach the 3 databases that we just deployed. And to do that, we'll just add the following 3 destinations inside Audigos: Loki, Prometheus, and Tempo. To do that, you just need to enter these URLs as mentioned over here. These are also present in the resources section, so feel free to use them from there. And all you need to do after this is wait a few seconds for Audigos to finish deploying the required collectors and instrument the target applications. And now finally, the last step is to explore our observability data in Grafana. We can now see and correlate metrics to traces to logs in order to dive deeply into how our application behaves. And to do that, we'll need to port forward a Grafana instance by running the following command. Then we navigate to localhost, enter admin as the default username. And for the password, you need to enter the output of this following command. Please note that there's a percentage symbol at the end of the string. Make sure that you remove that while you're entering it into the password. And now, time to see the power of data. So just log on to your Grafana instance. And we'll start by viewing a service graph of our microservices application. To do that, just go to Explore over here. Make sure Tempo is selected on top. Choose the service graph and just run the query. And there you go. You have a basic node graph available to you with a single user service application. Now let's view some metrics, right? So we'll click on the user service and we'll choose request rate. And there you go, a graph for all of the metrics that we want is presented to us. There are 3 kinds of metrics that Audigo supports. Firstly, it's metrics related to running of the application, that is number of HTTP requests, latency, DB connections. Secondly, metrics related to the language runtime, that is threads, heaps, all of that. And metrics related to the host environments, which is CPU, memory, and disk usage. So now let's look at some traces, okay? So this time we'll click on the user service and just select histogram. And in order to correlate metrics to traces, we'll use a feature called exemplars. To show exemplars, we'll need to click on options over here and just enable them, exemplars. These tiny diamonds will be now visible to you. You can just select any of these and click on query with Tempo. And there you go. A trace like this should be present to you. You can see exactly how much time each part of the entire request took, and digging into one of the sections will show additional information such as database queries, HTTP headers, and yeah. Now, if you want to drill down further, we'll go into logs, which is through Loki. And you can just simply query the relevant logs as we need it. So to that, we'll just firstly choose our namespace and use this trace ID as an identifier and just run this query. And there you go. You have all the data relevant to this particular trace, and you can map what it did end to end. And that is your observability framework for you guys. So we learned how easy it can be to extract and ship logs, traces, and metrics using only open source solutions. And in addition, we were also able to generate traces, metrics, and logs from an application within minutes. We also have the ability to correlate between different signals. We correlated metrics to traces and traces to logs. And most importantly, we have all the data we need to quickly detect and fix production issues on target applications. So great, we will now be able to detect and have all the data to diagnose and fix issues. But how do we approach incident management here for quicker resolution? So an appropriately observable system is definitely a must for quick resolution, but make sure that you don't lose the war against time during firefights due to human errors or miscommunication. Assess whether your organization could benefit from an incident response tooling like Zenity to keep responders on the same page, harness context-rich data from your observability plane, and enable your team to jump back from issues as fast as they can. And that's all my time. Thanks a lot for tuning in, and I hope you take something valuable away from this session. The resources link is right here again. Feel free to reach out to me on Twitter or LinkedIn in case you have any questions, and have a great day ahead.